Look at a spinning sphere. It seems simple, right? It spins, but its shape never changes. That's what we call continuous symmetry. It's beautiful to see, but for centuries it was a nightmare to calculate. Until a Norwegian named Marius Sophus Lie looked at it and saw a structure that no one else saw. He created a mathematical language so advanced that, at the time, almost no one understood it. But today, without his discoveries, we wouldn't have particle physics or quantum mechanics. Today you'll learn the story of the man who taught us to calculate the impossible.
The greatest mathematicians of all time. Episode 27. Marius Sophus Lie.
Marius Sophus Lie was born on December 17, 1842, in Nordfjordeid, Norway, and died on February 18, 1899, in Christiania, now Oslo, Norway. Sophus Lie's father was Johann Hermann Lie, a Lutheran pastor. His parents had 6 children, with Sophus being the youngest. Sophus initially attended school in the city of Moss, a port in southeastern Norway, on the eastern shore of the Oslo fjord. In 1857, he enrolled in the Nissen Latin private school in Christiania, a city that became Christiania and later Oslo in 1925. While studying there, he decided to pursue a military career, but his eyesight was not good enough, so he abandoned the idea and enrolled at the University of Christiania.
At university, Lie studied a wide range of sciences. There was certainly some mathematics in that course, and Lie attended lectures by Ludwig Silo in 1862. Although not a permanent faculty member, Silo taught a course, substituting for Broch, in which he explained the work of Abel and Galois on algebraic equations. Lie also attended lectures by Karl Birknes on mathematics, so he certainly had teachers of considerable quality. But he graduated in 1865 without having demonstrated great aptitude for the subject or great appreciation for it. A period followed in which Lie could not decide which area to pursue, and he taught while trying to make a decision. The only thing he knew he wanted was an academic career, and he thought for a while that astronomy might be the right subject. He learned a little mechanics, considered whether botany, zoology, or physics would be the right subjects, and, in general, was quite confused. However, there are indications that, from then on, in 1866, he began to read more and more mathematics, and the records from the library of the University of Christiania clearly show that his interests were constantly turning in that direction.
It was during the year 1867 that Lie had his first brilliant mathematical idea. It occurred to him in the middle of the night, and, overcome with excitement, he ran to see his friend Ernst Motzfeldt, woke him up, and shouted, "I've found it! It's quite simple!" Of course, this did not mean the end of Lie's problems, far from it, as Lie would always have problems, but at least in his own mind he now knew what career he wanted to pursue, and it would be fair to say that, from that moment on, Lie became a mathematician. The type of mathematics that Lie would study became more clearly defined during 1868, when he avidly read articles on geometry by Placker and Poncelet. The monumental idea of creating new geometries by choosing figures that were not points, in fact, straight lines, as elements of space, permeated all of Lie's work. In 1869, Lie wrote a short mathematical article, which he published at his own expense, based on the inspiration that had struck him in 1867. He elaborated a more detailed exposition, but the mathematical world was too cautious to readily accept Lie's revolutionary ideas. The Christiania Academy of Sciences was reluctant to publish his work, and at this point Lie began to despair that he would not be accepted in the mathematical world. His friend Motzfeldt did an exceptional job of encouraging him to pursue his mathematical ideas, and the breakthrough occurred in 1869 when Creel's journal accepted his article. He sent letters to two Prussian mathematicians, Rey and Klebsch, still trying to gain recognition for his ideas. The article in Creel's journal, however, proved vital, because thanks to it, Lie received a scholarship to travel and meet leading mathematicians.
Leaving at the end of 1869, Lie went to Prussia and visited Göttingen and then Berlin. In Berlin, he met Kronecker, Kummer, and Weierstrass. Lie was not attracted to the style of mathematics of Weierstrass, which dominated Berlin. His interests aligned more with those of Kummer, and Lie presented his own results at Kummer's seminar and was able to correct errors that Kummer had made in his work on congruences of lines of degree 3. Most important for Lie, however, was the fact that he met Felix Klein in Berlin. It was easy to see that the two would immediately find common ground in mathematics, since Klein had been a student of Plücker, and Lie, although he had never met Plücker, always said that he felt like a student of Plücker. Despite the common link through Plücker's geometry of lines, Lie and Klein had quite different personalities. It was in Berlin that Lie developed a new self-confidence in his mathematical ability. He received much praise from Kummer and replies from Rey and Klebsch to his earlier letters, which greatly encouraged him. Lie wrote to his friend Motzfeldt in Christiania saying, "In the years 1864 to 1868, I really underestimated my own mental power."
In the spring of 1870, Lie and Klein were together again in Paris. There, they met Darboux, Charles, and Camille Jordan. Jordan seems to have succeeded in a way that Silo did not, as he made Lie realize the importance of group theory for the study of geometry. Lie began to develop ideas that would later appear in his work on transformation groups. He began to discuss these new ideas about groups and geometry with Klein, and would later collaborate with Klein on the publication of several articles. One of the results of this joint work was Klein's characterization of geometry in his Erlangen program of 1872 as invariant properties under the action of a group. While in Paris, Lie discovered contact transformations. These transformations allowed a one-to-one correspondence between lines and spheres, so that tangent spheres correspond to the lines that intersect them. While Lie and Klein were deeply reflecting on mathematics in Paris, the political situation between France and Prussia was deteriorating. The popularity of Napoleon III, the French emperor, was declining in France, and he believed that a war with Prussia could change his political fortunes, as his advisors had told him that the French army could defeat Prussia. Bismarck, the Prussian chancellor, saw a war with France as an opportunity to unify the southern German states. With both sides feeling that a war would be advantageous, the Franco-Prussian War became inevitable. On July 14th, Bismarck sent a telegram that infuriated the French government, and on July 19th, France declared war on Prussia. For Klein, a Prussian citizen who happened to be in Paris when the war was declared, there was only one possibility. He needed to return to Berlin quickly. However, Lie was Norwegian and found the mathematical discussions in Paris very stimulating. He decided to stay, but became anxious when the German offensive met with only an ineffective French response. In August, the German army surrounded part of the French army in Metz, and Lie decided it was time to leave, planning a march to Italy. He arrived in Fontainebleau, but was arrested there as a German spy, as his mathematical notes were considered top-secret coded messages. Only after Darboix's intervention was Lie released from prison. The French army surrendered on September 1st, and on September 19th, the German army began to blockade Paris. Lie fled again to Italy, and from there returned to Christiania, passing through Germany to meet and discuss mathematics with Klein. In 1871, Lie became an assistant at Christiania after obtaining a scholarship, and also taught at the Nissen private Latin school in Christiania, where he himself had been a student. He submitted a dissertation on a class of geometric transformations written in Norwegian for his doctorate, which was duly granted in July 1872. The dissertation contained ideas from his early results published in Krell's journal, as well as work on contact transformations, a special case of these transformations being a transformation that maps a line onto a sphere, which he had discovered while in Paris. It became clear that Lie was a remarkable mathematician, and the University of Christiania reacted very positively, creating a professorship for him in 1872. The famous Norwegian mathematician Abel had died more than 40 years before this, about 14 years before Lie's birth. But despite Abel's short career, his complete works had not yet been published. It was natural that Norwegian mathematicians would undertake the task, and between 1873 and 1881, Sulo and Lie prepared an edition of Abel's complete works. Lie, however, always maintained that most of the work was done by Sulo. Another event that occurred in the 2 years following Lie's appointment to his chair was his marriage. He married Anna Birch, and they had 3 children, a daughter and 2 sons.
Lie had begun examining partial differential equations, hoping to find a theory analogous to the theory of Galois equations. He wrote, "The theory of differential equations is the most important discipline in modern mathematics." He examined his contact transformations, considering how they affected a process proposed by Jacobi for generating additional solutions of differential equations from a given one. This led him to combine the transformations in a way that Lie called an infinitesimal group, but which is not a group according to our definition, but rather what we now call a Lie algebra. It was during the winter of 1873-74 that Lie began to systematically develop what would become his theory of continuous transformation groups, later called Lie groups, leaving behind his original intention of examining partial differential equations. Later, Killing examined the Lie algebras associated with the Lie groups. He did this quite independently of Lie, and apparently not in a way that Lie considered satisfactory, and it was Cartan who completed the classification of the semi-simple Lie algebras in 1900.
Although Lie was producing highly innovative mathematics, he grew increasingly saddened by the lack of recognition he received in the mathematical world. One reason was undoubtedly his isolation in Christiania, but a second reason was that his papers were not easily understood, partly due to his writing style and partly because his geometric intuition far surpassed that of other mathematicians. Klein, realizing the problems, had the excellent idea of sending Friedrich Engel to Christiania to help Lie. Engel had received his doctorate in Leipzig in 1883, having studied with Adolf Neher and written a thesis on contact transformations. Klein recognized that he was the right man to assist Lie, and at Klein's suggestion, Engel went to work with Lie in Christiania from 1884. He worked with Lie for 9 months, leaving in 1885. Engel was then appointed to Leipzig, and when Klein left the chair in Leipzig in 1886, Lie was appointed to succeed him. The collaboration between Engel and Lie continued for 9 years, culminating in the joint publication of the 3-volume work Theorie der Transformationsgruppen between 1888 and 1893. This was Lie's major work on continuous groups of transformations. In Leipzig, Lie's life was quite different from that in Christiania. He was now part of the mainstream of mathematics, and students from many countries came to study with him. However, his teaching load was much greater. Lie's lectures on his own research were very well received by the students, in contrast to his mandatory lectures on standard topics, which were somewhat unpopular. He preferred to draw a picture rather than present rigorous demonstrations.
However, all was not well. He still felt unappreciated. In Leipzig, Lie was tormented by a constant homesickness. Passionate about outdoor activities, he missed the forests and mountains of Norway. In the late 1880s, Lie's relationship with Engel deteriorated. In 1892, the long-standing friendship between Lie and Klein came to an end, and the following year, Lie publicly attacked Klein, saying, "I am not a student of Klein, nor is the opposite true, although that may be closer to the truth." It is difficult for any biographer to represent these events and the events that followed fairly, since there is much contradictory material in the literature. The reason for this is not difficult to understand, as information about Lie was for many years based on annual reports of the German Mathematical Society that Engel wrote about Lie's death. The situation is complicated by the mental difficulties Lie suffered in 1889. Klein writes, the, quote, defense of Lie's behavior, referring to the close relationship between genius and madness, actually created a generally accepted explanation that has survived to this day. With this act of, quote, defense, end quote, Klein committed an incredible injustice against his old friend. The truth is that Lie's behavior was not entirely irrational, as portrayed, but rather motivated by the way Engel and Klein behaved. W. Purkert discusses the breakdown in relations between Lie and Engel. He studied material from the University of Leipzig and believes that Lie changed his attitude towards Engel because he still felt a lack of recognition, even though he knew he belonged to a different category as a creative mathematician compared to Engel.
Lie returned to Christiania in 1898 to assume a position created especially for him. He prepared a report on who should occupy his chair, and this report is presented in full in W. Purkert on the relationship between Sophus Lie and Friedrich Engel. Although Engel was one of the leading researchers in Lie's field of research, Purkert believes that Lie's assessment that he lacked creativity was entirely fair. In Some Observations on the Illness of Sophus Lie, B. Fritsche comments on Lie's illness. He writes, "Through information about Sophus Lie's illness, it is possible to trace consequences that shed light on certain biographical aspects of his life. For example, his break with Friedrich Engel and Felix Klein. Furthermore, this evidence contradicts the frequently held opinion that Lie's illness was caused by overwork." And Straumer, in Sophus Lie, Newsletter of the European Mathematical Society, points out why Lie's behavior towards Klein, culminating in their break in 1892, was not irrational. Klein's Erlangen program of 1872 had not attracted much attention. In fact, it was Lie and not Klein himself who influenced the mathematical development predicted in that program. Klein decided to republish the program and also write about its origins, in which Lie was quite involved, but Lie vehemently disagreed with Klein's views on what had happened in the past. It was also discovered that Klein burned all the letters he had received from Lie up to 1877, thus breaking a previous mutual agreement between them. Lie reacted by publicly attacking Klein in the preface to the third volume of his work Theorie der Transformationgruppen in 1893. Certainly, Lie was an angry man, but he was attacking someone who occupied such an important role in the world of mathematics that it was more likely that the attack would backfire on Lie than harm Klein. Recent research already shows Lie in a much more favorable light in this case, and therefore Klein in a less favorable light than previously thought, and everything indicates that future research will be even more favorable to Lie.
Perhaps an indication of Lie's love for his homeland is the fact that he continued to hold his professorship in Christiania from his first appointment in 1872, officially being on leave while holding the professorship in Leipzig. However, his health was already deteriorating when he returned to the professorship in Christiania in 1898. The end of Marius Sophus Lie's life was marked by the rapid and severe physical decline caused by pernicious anemia. In his last days in Christiania, or Oslo, the disease progressed aggressively, completely draining his vitality and leading him to a state of extreme weakness and pallor. Confined to his bed and without effective therapeutic options available in late 19th century medicine, his body could not withstand systemic exhaustion. Death was confirmed on February 18, 1899, when he was 56 years old, resulting from collapse. Physical death caused by illness. Sophus Lie died before seeing the true scope of his work. He didn't know that his equations would be used to describe the workings of stars and atoms. He studied symmetry for the beauty of symmetry. This teaches us that pure knowledge is like a seed. The one who plants it doesn't always see the giant tree that will grow, but the future will be grateful. And you, had you heard of Sophus Lie? And if you love discovering the story behind the numbers, subscribe to the channel now. Mathematics is a human story, and we are only beginning to tell it.